Hey, so I wanted to go over this roller coaster problem we were looking at in class. So you're at point A, this roller coaster at rest, and you want to figure out how fast you're going to point B. First of all, energy is conserved because there's not a lot of loss to heat, sound, or light. So let's write that down. Energy is conserved. No heats, sounds, lights. Okay, so E1, or EA, I guess I could say, equals EB. Well, the energy at point A, let's see. At point A, it's just got potential energy, UG, right? Because it's not moving over here. It's 100 meters up. EB, it's got some potential energy still. It's 50 meters up. I'm sorry, it's UB. UG point B. I guess I call that UG at point A. Plus the kinetic energy at point B. All right. Now I'll just plug in. I guess I'm calling the bottom zero height. So then UGA equals MGH equals M or HA equals MGHB, just so I don't call them the same height, plus 1/2 mv squared. I'll divide out the masses. That happens a lot, right, guys? You'll notice it keeps happening. And then I'll just plug in, right? So voila, that's where I am. And now I'll just do some math. Okay, just did 9.8 times 100 minus 9.8 times 50. Got 490. I'll multiply by 2. I'll get 980 meters squared per second squared equals v squared. And v equals 31 meters per second. Okay, as some of you pointed out though, I don't have to call the ground zero. Couldn't I redo this problem and call point B zero? Isn't that the smart thing to do? Let's do it like that. So, same problem as before, only I'm going to call this zero height. That just makes sense. Okay, same E1 equals E2 because energy is just as conserved when I make the ground zero as when I make point B zero. And now I'll just say, well, what kind of energy is point A? It's still got potential only. What kind of energy is there at point B? It only has kinetic now. Isn't that nice? Because there's no potential, because the height's zero now, right? I mean, I could multiply m times g times 0, but guys, I'm just going to get 0 for the potential energy if I call that zero height. So now I just plug in. Let's see, mgh equals 1/2 mv squared. Cancel out the m's. What's h now? That'll take a slight bit of thought. H is if this is zero height, and h is this distance over here. Actually, let me change colors. H is this distance over here. Well, that's just going to be 50 meters, right? Because it's going to be a full 100 minus this 50. So it's just going to be 9.8 meters per second times 50 meters equals 1/2 v squared. I'll do a little math on that, and I'll get v equals 31 meters per second, right? I think that's easier. So, like, guys, the general rule, I think, is you want to call zero height the lowest height that is being used, the lowest height anything gets to. It just makes your math easier. All right, guys, take care.